now we will look into electrical services, some introduction to that. Now, first thing is in India, of course, in small buildings we supplies alternating current, single phase, 220 volts, 50 hertz, and of course, large buildings 3 phase supply will come, but finally all your most of your appliances, domestic or the similar kind, they are all single phase, right, they are based on single phase supply. Now, having said that, use of solar energy, I mean solar, use of solar cell driven electrical system, people would prefer possibly DC, because the photovoltaics, they generate DC, and it has been suggested that if the appliances are all DC, then you do not have to have conversion, reconversion, etc., where there are a lot of losses. DCs were used in previous century or previous, somewhere in the beginning of 20th century, because it is more efficient. You can, efficient, losses are less, etc., etc., and generation is also, it is easy to generate 3 phase supply rather than DC. So, electrically that is more, these are more efficient. Okay, but we will talk about this system only. So, if you look at it, typically you will have lamps which in India would be 220 volts, right. Say you might have a 3 phase supply in a large building. Now, okay, let me see if I have something here more, not really. Okay. So, in a single phase supply you have 2 wires, live and neutral. Usually this is black, this is black, this is red. Usually this is black and this is red. Now, we know that our supply voltage is sinusoidal, right, sinusoidal. So, single phase means I have with 50 hertz frequency sinusoidal voltage. 3 phase means I will have 3 phases which will be 120 degree out of phase, peak to peak would be 120 degree, means 360 is the complete cycle from starting from here to here. So, this would be 120 out of phase. So, therefore, 3 phases, the peaks appear at different time because it is sinusoidal. So, lamp etc., we have single phase connection, right. Some 3 phase motors are used where 3 phase motors would require 3 phase input supply. So, this is, as I said, 220 volts, 50 hertz, and this is a heater that also is similar kind. Yeah, and in some cases, of course, we do not have any appliances of 110 volt, but supposing you have something of the 110 volt, you might use a transformer which converts, which steps down this 220 volts to 110 volts. Obviously, the current will increase, right. So, transformer is nothing but a magnetic, you will have a magnetic core and you have a coil around this side, this primary, this is a secondary. So, this one change in, you see the in alternating current there is a change in current or change in and change in voltage as well. So, that can induce magnetic, that can increase magnetic, and it can change magnetic, it can have induce the magnetic current, and that in turn can induce electric current in the secondary itself, right, the secondary itself, all right. So, that is the idea, that is the basically idea. This is transformer is a AC alternating machines, alternating current machines, essentially you can step down your voltage to higher voltage to lower, or increase the lower voltage to higher voltage using this magnetic core or the transformers here. So, this is we do not need this much these days, we do not have most of it is standardized to 220 volts. So, as I said, in single phase supply you have got live and neutral. In 3 phase supply you might have a 4 wire system or 6 wire system. Now, this is a diagram of the, so line 1, line 2, line 3, these are 3 phases and connects to a 3 phase electric motor connected in star form, this is called a star form, right, and L1, L2 and L3. And for single phase system, neutral is, of course, neutral is, I mean, it is not connected to the line, it is not, it is actually return path, it provides the return path. So, neutral provides the return path, and there of course has to be a earth. Earth is to avoid getting accidental shock from accidental leakage current. So, the neutral is essentially provides the return path even in single phase scenario. So, you take any line and the neutral, that will be a single phase supply. That means, you have line voltage, line to neutral, that is the voltage that you will get. Line to line voltage is different, between 2 lines voltages would be different, and we talk in terms of all RMS voltages, because sinusoidal. So, root mean square, because some of the voltages, I mean, is periodic. So, when you have periodic situations, what you do? You take, you depict or speak in terms of what is called root mean square values. So, there is an amplitude, there is a peak amplitude value. So, amplitude, peak amplitude value, but then you want to talk in terms of average. If you just take arithmetic average, it will become 0, because there is a positive area and negative areas are all same. So, what I do? I integrate this square of this, right. So, V at any time, because V, if it is amplitude, V sin omega t or whatever it is, square it up, square will be always positive. So, then divide by the base and take under root. So, root means square, root means square. So, square it up, take mean the root, and you can calculate out relationship between peak voltage and the RMS voltage. So, when we say 220 volts, we always talk in terms of RMS voltage, root means square voltage, right. So, anyway, so that is what it is, right. So, in this one, so 3 phase motor should be connected to 3 phases and the neutral. So, 415 volt 3 phase motor, something 440 volt. Oh, sorry, it is connected, yeah, the 3 lines are straightaway coming, it is connected to the earth straightaway, that is because for the safety point of view we will look at this. So, neutral is 0 level. So, that is what it is. So, line voltage, line to line voltage of course differs, and line to neutral voltage, that is our 220, that is 440. You can calculate out this relationship, we will look into that if there is a need. Now, typical house connections would look something like this. Typical house connection would look something like this. This is from National Building Code or similar literature you will get. So, essentially these days these are gone. These are the what we call earlier fuses or cutouts, So, what would they do? You need a safety. So, if the excess current is flowing, these were they will simply melt at high temperature, So, temperature would be high and they will simply melt and disconnect the circuit. So, the things do not burn, right. So, high current means I square RT. So, it will start burning. So, if you can see this, so I have got first the there is a this is of course this live is coming, and this is through fuses. Maybe I have another diagram which will show switches. So, this one connects like this, there is a switch here, this connects to the socket, like you have 2 types of socket, 5 ampere and 15 ampere sockets in our domestic lines. So, one is the power, another is that would draw a higher current, it is only the sizing, it is a single phase only. So, another 5 ampere, the current drawn would be relatively less. So, because the appliances are there, they are classified in this manner. Many heaters will be actually 15 ampere or power, they will be connected to the power, your air conditioning system, air conditioner, house air conditioner, they are all connected to power, while you have lamps etc. are connected to simply 5 amperes. So, all the time you will have a switch here, main switch will be somewhere there actually, mains for the whole, and then you have got fuse. Then this is a switch, switch is always connected to the live, switch is always connected to the live, not to the return circuit, but this only skilled people will do that. It is not connected anywhere, and if the color quantity is maintained, then it is safety. So, even if you see a pin, 5 ampere pin, you look at it, I mean 5 ampere pin, you will find that L and N is written. In one pin it will be written L, another is N. So, that is what it is. So, the pin connects, the switch is here and then it returns, right. So, all returns are connected to the neutral. So, live and the neutral, two lines, right. Switch is always on the live line. So, this is this, and all of them are connected in parallel. For example, if you have two of them, both will be connected in parallel. So, your all loads are parallel, the other load is all parallel. The switch will be somewhere here in the live, neutral side it is the return. So, switch will be somewhere there for each individual one, right. So, these domestic connections are typically like this, right. The earth is important. This is a typical diagram of a earthing system. Now, why I need earth first, let us come to this. Okay, this is a diagram given in National Building Code. I hope I have got earth here, not really, no diagram for earth. Okay, no, not really, no diagram for earth. Okay, earth is needed basically by chance, by mistake, if you, this is your appliance, and if there is a leakage current, right, if there is a leakage current somewhere and the human body touch, so you touch, so it normally flows through the least resistance path. So, you touch this, it might go through the body, but supposing it is all connected to the earth. So, instead of following this path, it will straight away go there. So, it is a safety device essentially provided everywhere, and that wire is usually green. So, 3 pin socket, if you look at it, there has to be 3 color, single phase. L stands for live, N stands for neutral, and the green is the earth, green is the earth. So, wherever you need appliances are connected, they should be connected in following this principle. Code gives you the dimensions of earth. What is done is all earth wires are connected together, they are all connected together, and then they are connected to this kind of a system which is buried deep into the soil, deep into the soil. So, typical constructions are given. In fact, you should have a sand layer, or different layers are given actually. What should be the material, how much depth below the earth is there, this is suggested, and this is buried and all are connected to that. So, this essentially ensures that the current flows to the mother earth, which is the ground zero, it can absorb anything. So, that is what it is. So, earthing is very important, right. So, this is some other diagram of the earthing is given. Okay. So, details of such earthing for different cases, these are given. Again, we do not have to do much about them, but these are available in building code or similar bodies, it has to be adhered to. The other one is of course, is important issue is of course related to breaking the circuit in case of high current. So, earlier we were using fuses, and which would have had some kind of a current rating. So, what did you do? As the reaction time of such system is very important. As the high current comes, after how much time actually it breaks off the circuit was important. Previous ones would be using metals which will get heated up and then melt and disconnect the circuit, but current ones are essentially based on solenoid principles. I will come to the site one next. Solenoid principles and look something like this, I mean principle looks something like this. So, what you have actually, this is your you have a switch, double pole switch, this is a live and neutral wire, double pole switch. Now, it is connected to a electromagnetic core, right, electromagnetic core. So, live wire goes like this and this goes to the load, this goes to the load, right. Similarly, neutral wire comes like this, it is wrapped onto the secondary. So, this is the primary and this is the other side of the magnetic core. Now, basic principle of a transformer, that when you have a coil wrapped around a magnetic field and the current is varying, right, according to all those laws, Lenz's laws, if you recollect Faraday's laws, etc., it will it will induce the current, induce a magnetic field, and there is a magnetic core. So, there is a kind of this magnetism, induced magnetism will flow through this. So, magnetic circuit is completed through the whole core. So, if you have another coil there, the variation of the magnetic field would result in inducing current. For example, if you remember good old days, people would have shown you an experiment in BTech or even school level, they would have shown you. If you have a coil, suddenly you put a magnet inside a magnetic field, there will be a galvanometer which will show there is a deflection. So, if the magnet so there is a variation of the magnetic field, because when you insert a magnetic field is varying and it induces current into the same thing. So, this is what would happen here. Now, in case of normal condition, when there is no high current flow, right. So, live goes like this coils and then it goes to the load, neutral goes like this and its coil goes to the electric load, right, and there is another connector, there is a residual circuit. So, if the situation is balanced, if the current is not too high, this current passing is not too high, what will happen is actually there is of course this one which is connected to a solenoid circuit breaker, the residual current circuit actually. So, normally if you, for example, supposing it is going directly, supposing it is going directly, this is a test button here, it is going directly to the electric load, right. So, the short circuit would occur. If there is a short circuit, for example, this is causing a short circuit, this switch is on, would cause a kind of short circuit, it is going to the live back again. In such situation, what will happen? The neutral will not operate, this magnetic field will operate, this will induce a magnetic field here and the solenoid will break the circuit. When there is a normal condition, this is not operating or there is no short circuiting or something happening, the current will flow like this current flows like this, this live current flows like this, right, and the neutral current flows through this, they balance each other. The balance, the neutral current flows like this, they balance each other, there will be no residual magnetism available there, because this whatever it generates is neutralized by this, whatever it generates, because neutral is also coming through the same, right, return current and direct current is also going through the same. So, this is all balanced, there is nothing, no residual current is not generated there. In case of residual current in this, that means live current and neutral current, there is something has happened here. Maybe there is a short circuit or something, there is excess current flowing, they would be differing and that would result in residual current circuit to act and activate a top solenoid, which is again a magnetic device which will break the circuit. So, that breaks it here, the straightaway breaks it the switch level. So, that is how a circuit breaker works and which are much more efficient. Anyway, today the other ones have already got they are obsolete. So, so if one looks at it, the reaction time, right. So, RMS current versus 15 ampere cartridge earlier ones, this is time, response time 15 amperes. So, as soon as current goes above 15 ampere, this should this should break off. So, 15 ampere circuit breaker, the time required is, you can see that time required is, this would time required for, this is the circuit breaker, as soon as your current, this is your 15 ampere current goes higher 60 ampere or something, right, it would, the time instantaneously, the time is shown, it would react within this is the 1 15 ampere 10, this is how much, this is this is 1 second 15 ampere. So, this starts immediately 0 second as the current starts increasing, this is time is 10 second, 20, 100, 1000, 10,000 seconds. So, if it is just 15,000, it would require 10 seconds, right. Here it will not act even at 15 ampere, it will only act at somewhere around something like that, something like that 60 or 70 ampere. So, at 60 ampere this will possibly straight away within 0.01 second it will react, it will react within 0.01 0.04 second into 0.04 seconds. So, it is 60 ampere. If it is 100 ampere 0.01 second, whereas at 100 at 100 ampere it will take 0.1 second. So, this is the curve for the old ones cartridges, 15 ampere cartridges. This one has something like this. So, 62 like 62 this is how much 62 15 ampere 60 ampere straight away it cuts off within this period of time, and if it is somewhat less then it takes 20 seconds or 10 seconds. So, actually time wise it is much more efficient. This curve gives you the time wise performance of the two. This is for the 15 ampere cartridge, this is for the circuit breakers. So, that is why it has got all replaced by circuit breakers today. You do not see any more these cartridges anymore. Okay. So, this is one issue. The other issue is important, the power generated, why alternating currents were used actually. The power generated is transmitted at high voltage to avoid conductor losses, very high voltage low current, right. So, 3 phase generation is easier, transmission is easier. Cable capacity you can calculate out very easily, but it is tabulated also. For example, it is pretty simple. Cable capacity you want to calculate out, we know that resistance is equals to rho into L over A, right. So, A is important, rho is the resistivity. So, the conductor that you are using or resistance material that you are using. So, you will talk in terms of resistance per unit length R by L, right, rho into A. So, area or mass, current rating, So, this is current rating. So, V is fixed to 20 volts, V equals to IR, and R is nothing but R per meter length. So, if I have 15 ampere current, let us say, then for 15 ampere current is flowing. So, this is I, and for 1 meter length of the wire, let me say this will be rho by A. So, how much area I need, that I can find out, how much area I need I can find out, how much area I can need, that means size of the metal or cable size, that would be known to us, right. So, ratings of cables are given in terms of ampere, but actually area increases with rating, area increases with rating, area increases with rating. In fact, I and 15 by A, right. So, resistivity is constant. So, 15 by A is equals to, if I increase the area, rating also increases. So, it is directly proportional, depend upon rho per meter, rho, it will depend upon rho, and rest of the thing voltage etc. or current rating. So, current rating is directly proportional to area, current rating is directly proportional to area. So, this is given in tabular form. In fact, this is given in a book, which I have given you in reference. It is given in cable capacity. So, it gives you capacity and voltage drop across that you can find out, which will be equals to IR. I into R is the voltage drop about for a given length. So, voltage drop per meter length, how much voltage drop you expect, that you can so you can calculate out. So, this is given cable capacity voltage drop for given areas, this is given actually. AC is more economical and convenient supply. The load must be, now when you have AC, then one thing, you see, in alternating current energy can be stored. All energy is not dissipated or converted into work. Anyway, for example, you can generate heat, and also or current, electrical energy can be used to do direct work. In a magnetic field, the motor can rotate and things like that. So, direct work. Now, also I can have DC motors as well. So, therefore, motors can be either DC or alternating, that is not a problem. But in alternating current, I generally I can store the energy, not all are converted into energy. The amount of energy that can be converted is basically I square R watts or I square RT. So, resistances can generate heat or consume the electrical energy, or where energy is converted into electric, work or something of that kind. It is essentially the resistive energy. While if you have a coil, in a coil, if the current, varying current is passing, it can generate magnetic field around it. A steady current in a steady magnetic field does not make any difference. But if you have a coil where varying current is being produced, then this varying current would actually generate a varying magnetic field, a back EMF, etc., etc. So, this is an inductor is based on this principle, which will generate a back EMF, and it stores the electrical energy into magnetic energy. Similarly, a capacitor stores the electrical energy and it as charges and releases it. Now, this can only happen when there is a variation. For example of a capacitor is like this. If you have a steady current, the plate will get charged and then it will remain as long as you have applied the voltage. When you put it off, it will get discharged. But in alternating current, it will once get positively charged, next time it will get negatively charged. So, therefore, the current can flow. Current is basically vibration of the electron about the mean position of equilibrium, which can occur. So, actually a capacitor do not consume any energy, but it stores the electric field, stores the electrical energy. So, they do not consume. So, you have equivalent what we call impedances, reactances, and I combine them, I get what is called impedance. So, in case of alternating current, I may have some inductive load in the circuit. For example, earlier days, if you have seen your fluorescent lamp, tube lamp, you would have a choke. Now, the choke is actually nothing but a inductor. You would have a starter which will give a voltage, initial voltage for starting the voltage, so that the the electric field it can actually work between the electrode. So, that was a capacitor essentially. So, when you have such loads, number of them, lot of actually energy is not utilized, rather stored, and it is not a good thing, because your voltage, supply voltage or supply VI, voltage into current will be high, because some of it will be actually stored. Now, this aspect is taken care of, or rather looked into. So, ratio of the resistance to total impedance, that we call as power factor. More the resistive load, more is actual utilization of the electrical energy. More is the inductive load, less is the utilization of the energy, where your VI required will be higher. So, it is written in terms of VI cos theta. I will discuss this some maybe next class. So, essentially power factor is an important issue. You would like to have high power factor, because you would like to have higher utilization of the energy. Okay. So, I think we will stop here.